All right, so this was a fairly basic question, 2005 B, question number 2. And basically, the big thing on this was making sure you knew how to show your work, because I think most everyone is fairly comfortable with actually doing the calculator part of this, but you have to show your work in order to receive the credit. So that was the main reason I wanted to go through this problem. So for an upcoming concert, each customer may purchase up to 3 child tickets and 3 adult tickets. Let C be the number of child tickets purchased by a single customer. Probability distribution of the number of child tickets purchased by a single customer is given in the table below. All right, so compute the mean and standard deviation of C. First off, from a calculator perspective, I would just gone to stat edit and I would have put C into L1 and the probability of C into L2. So 0, 1, 2, 3 in L1, 0.4, 0.3, 0.2, and 0.1 into L2. And then I would have done the stats calc, one variable statistics, in order to get my expected value, so my X bar. And but to show my work, I needed to be showing 0 times 0.4 plus 1 times 0.3, etc. And when I do that, I get 1.0. And so on average, we expect a customer to purchase 1 child ticket. So then the question is, do I have to include the sentence? And the answer is some years. So please do. In this particular instance, they did not require it, but some years they do. So on average, we expect a customer to purchase 1 ticket. So, and it's real important, and I think Ms. Lamb will agree with this, that you write the word on average and then we expect. That would be what you do for expected value. For the standard deviation, they weren't nearly as important, although I should have put the units on there. Once again, you needed to show your work. I know the calculator, when you did your stat edit, gave you that. And because this was a discrete probability distribution, and I say it's discrete because the numbers could only be 0, 1, 2, and 3, then we will actually only have the population. S wouldn't even have shown up as a possibility. So 0.4 times 0 minus your mean, 0.3 times the 1 minus the mean, 0.2 times 2 minus the mean, and of course each one is squared. And that would be your work shown. That should have been a fairly easy one to get. Now what it didn't ask you to do, and there are not a whole lot of examples on this, but I do want you to make sure that you can do it, because this is a reasonable question that would be easy for them to add to make it a little bit longer without taking a whole lot of time, is if they had asked you to compute the median. Now they didn't do that, but we know that the median is at the 50th percentile. So we're always going to work left to right. When we say, well, 0 is the 40th percentile, that's not high enough. As soon as I accumulate all the way, as soon as I cross over 50%, that's my answer. So my answer occurred at number 1. You go, well, that's at 70%. And I go, yes, it is at 70%, but it also included 50%. That is the only category that included 50%, because 0 included 40%, all the way up to 40%. But the median at 50% was included in the category of 1. So if it asked for median, that's what you would have done. Okay. Suppose the mean and the standard deviation of the number of adult tickets purchased by a single customer are 2 and 1.2. So we know the child tickets are 1 ticket for both the standard deviation and mean, but here we have a mean of 2 and a standard deviation of 1.2 for adults. Assume that the numbers of child tickets and adult tickets are independent random variables, and we need to note that. Compute the mean and standard deviation of the total number of adult and child tickets purchased by a customer. The reason it was important to know that there are independent random variables is I cannot combine standard deviations if they are not. They must be independent random variables to calculate standard deviations. They don't have to be independent to calculate means, but they do have to be to calculate standard deviations, and they ask for both. Well, combining means is easy. We just add them the way we normally would. So 2 plus 1 is 3. On average, we'd expect that a customer will purchase 3 tickets. All right? And in this case, it'd be basically 2 adult and 1 child is what we're typically expecting. But the standard deviation, we can't add directly. We have to convert it to a variance. So that becomes the 1 squared and the 1.2 squared. Then we sum that and take the square root. And so the combined standard deviation of adult and child tickets would be 1.562. The next one says, suppose each child ticket costs $15 and each adult ticket costs $25. Compute the mean and standard deviation of the total amount spent. Well, the amount spent is going to be based on how many you purchased. All right? So we purchased 1 child ticket. We expect to purchase 1 child, that's $15. And we expect to purchase 2 adult at $25. And we can multiply standard deviation. We can multiply means by a constant. So 1 times 15 plus 2 times 15. And we can just straight up add them. So the calculation for the expected is pretty easy, it's $65. It gets a little more complex with standard deviation. So there are 2 different ways to have approached this. And I'm going to approach it with standard deviation, then I'll talk about variance. All right? With standard deviation, I can multiply the standard deviation times a constant. So 15 times 1, I can do that. Or the 25 times 1.2, I can do that. So now my new standard deviation, it would be $15, or my transformed standard deviation is $15 and $30.5. But I need to combine those. And I cannot add them directly. So once again, I have to square them, then take the square root of them. That's probably the method that is most intuitive because you can always multiply a constant times standard deviation. On the other hand, had you wanted to work with variances, that's fine. But with variances, you don't multiply by a constant, you multiply by the constant squared. So in this case, we have 1 squared, because that's the 1 ticket, times the standard deviation, times the 15 squared, that's my constant. We have the standard deviation of 1.2 squared times my constant squared. And then we add those together and take the square root. And once again, we get exactly the same thing. However, I suspect the part that I'm trying to highlight, well, I guess it's not going to let me do it the way I want to. There we go. The part that I want to highlight, the part that I'm highlighting may make more conceptual sense because you're just multiplying by a constant. Whereas, because with standard deviation, you can multiply by a constant. With variance, you have to multiply by the constant squared. All right, so I'm going to